Welcome back. We're in chapter 15 on oxidation and reduction, and in this section we're going to talk about batteries. We're going to talk about how batteries work and something that you use every single day. Every time you charge your iPhone, every time you put batteries in flashlight, you're using a stored energy source, which is ions, and you've separated them somehow. And then when you give a connection, you're going to have a spontaneous chemical reaction. Now, there's lots of the different things that I've taught you in the past that relates to this. The activity series that we talked about, where gold, for instance, doesn't tarnish, but silver tarnishes, and other things tarnish even more. The activity series plays into it because something is going to have to be oxidized and something is going to have to be reduced. So every material doesn't oxidize or reduce every other material. Some are likely to be stolen from. You always have your 90-pound weaklings at the beach that you can steal their stuff. You can always have the kids that you can steal their milk money. So there is a series of every single element, all the metals especially, are putting it in a list of which one will more readily lose electrons to others. So the higher you are on the activity series, the more easy it is for you to lose the electrons and they're more easily oxidized. So how does a battery work? So let's first of all look at a battery. It is generating electric current by separating the two half cells that we did in the last lesson when you oxidize and then reduce. Okay, so you are stealing electrons and then reducing. You're stealing electrons from one atom and reducing another atom by its theft. Okay, so what's going to happen is if you can steal, if it's stealable, so if you can have an atom that more readily steals an electron from another, then you're going to have a spontaneous generation. And as soon as all of those electrons are gone, your battery is dead. Okay, so in our example, we're going to use two beakers and we're going to have some solution in those beakers. In your car battery, you kind of have beakers because you have a plastic box with some different trays in that box, each with some kind of a gel or a liquid in it, and then some kind of a metal in it as well. And the metals can be lead, it can be carbon, like a graphite, it can be all kinds of different things. But essentially, you're putting a metal in its metal salt. Okay, so in this example, this is going to be the anode, and the anode is the negative terminal of the battery, and the anode is where oxidation takes place. Remember, that's what's getting eaten away. The metal is losing its electrons to the solution. Okay, so this side is going out. The zinc is being converted into zinc ion, and this metal anode is actually deteriorating as it goes. Eventually, there's not going to be any zinc in the anode left, and then your battery would stop. Okay, in this case. So in this beaker, we have a zinc anode in some zinc solution. Okay, you're going to have some zinc sulfate in this beaker. You're also going to have what's called a salt bridge, which is a kind of a U-tubed piece of glass with some kind of a permeable into it and some gel that allows electrolytes to pass so that you don't have a buildup of charge on one side of the battery or another. It keeps the current flowing in the battery. And if we build one of these, you'll see it. Okay. So in this case, we have an anode. This zinc is going to be eaten away. So you have a zinc inside some zinc sulfate. On the other side, you have copper. Now, copper is lower down on the activity series. It's not as easily oxidized. That means it's going to steal the electrons from the copper, or from the zinc. The zinc is more easily oxidized. The copper steals the electrons. So it's going to be called the cathode, and the cathode is the positive terminal, the anode is the negative terminal, and the cathode is where it's reduced. That's where you're actually going to get copper to come out of this blue solution and plate this you're gonna have copper come and plate this. More copper is going to pile up on the old copper. So you're going to have a piece of copper metal, and then copper that's in the solution that's going to come out. So at the positive is where essentially you're going to get a pile up or reduction. That's called reduction. And then the charge is balanced with the salt bridge. So in this beaker, you've got copper metal inside copper sulfate. Okay, so you had zinc sulfate on the other, copper sulfate on the other, and copper is lower on the activity series, so it can steal the electrons from the zinc. Okay, putting it together, you have two half cells. You have the anode half cell, where zinc is being oxidized into zinc ion, and then you're going to have the cathode half cell, where copper ion is being reduced into copper metal, okay, by stealing the electron and canceling out this positive 2 charge and becoming straight copper. Okay, so your overall equation is zinc, okay, here's zinc metal, okay, plus copper 2 ion, that's found here, yields copper metal, that's going to be plated on this anode, and the zinc 2 plus, which is what's left over after the zinc disintegrates and comes into solution. So you're going to have zinc becoming zinc ion. So this is 0, this is positive 2, so this is oxidized. Zinc is being oxidized. The copper ion is gaining an electron, so it's being reduced into the copper metal. So if you remember before, we separated these two. This was in one side, and this is in the other side. Okay. Shorthand is the idea that zinc is being oxidized, that's what the line means, to the zinc metal, and the copper is being reduced into the copper, or the copper ion is being, the zinc metal is being oxidized into the zinc ion, and the copper ion is being reduced into the copper metal. And so this line here, separation, is showing you that you're actually having a electron transfer here. So these are two half cells. You're going to have one happening in one beaker, the other happening in another beaker. So when you have a battery, you essentially have two beakers. You have a little vessel inside a vessel. So you have like a big, the outside of a battery, that zinc casing is the outside of the battery. That's why it's that bottom part of the flat part of the battery is zinc. It's a zinc casing. And then you have an inside casing. So you have a chamber inside a chamber. So instead of like this, where you're going to have two chambers side by side, in a battery, you're going to have something more like an inside and an outside. Let me see if I can find one. We'll talk about batteries more. Here's a battery. The inside is going to be a graphite core that's just like a pencil lead. Then you have an inside chamber. The inside chamber has a manganese oxide compound where these are charged particles. So manganese is a positive and negative charged particle. And then on the outside, you're going to have zinc. So the zinc is going to be eaten away. The zinc is going to turn into zinc ion, and then the manganese is going to be reduced into a different manganese. You have this is manganese MnO2, and this is Mn2O3. So they have different charges. So the manganese is going to be reduced. The zinc is going to be oxidized. And what happens is when all of that runs out, your battery is dead. And then either has to be charged again. That's what's going to happen with your iPhone when you plug it in. You have to recharge your battery. Essentially, you're driving those charges back in. Or if it's a cheap battery that's not rechargeable, you just buy another one. Okay. And know that this is not all the information you need. We'll do more of this, showing you the nuts and bolts of this in the next lesson.